Connecting your branch to a wide area network used to be a simple enough proposition. You'd call up your carrier, you'd get a circuit ordered, you'd wait a long time, and then you'd turn the circuit up. There'd be a little bit of routing, and there you were. Everything was backhauled to the headquarters site, and it wasn't especially fast, and it probably cost too much, maybe way too much, but it worked well enough to get business done, right? And then cloud blew all of that apart. So now when we connect branches to our corporate networks, we have to consider not only the performance and the cost that we've always had to consider, but now also these other services that the branch is going to connect to and how to secure them. I'm Ethan Banks, and with me is Drew Conway Murray. We are your co-hosts for Heavy Networking, the flagship podcast from the Packet Pushers Podcast Network for IT professionals. You can follow us on LinkedIn, Blue Sky, and the Packet Pushers Slack group, which you can join for free at packetpushers.net/community. Joining us for our discussion about branch connectivity and security is Mitesh Patel and Graham Shepard from Palo Alto Networks, our sponsor for today's discussion. Mitesh, the first question goes over to you because I want to highlight something that I think is important here. When we think about branch connectivity, there is kind of that model I was describing in the intro, where it's some version of a circuit and there's connectivity there, maybe some encryption, maybe it looks like SD-WAN a little bit. But what modern branch connectivity looks like has evolved quite a bit. So if I'm a network engineer thinking about connecting my branch office here in 2025, what does that look like? What are the services that I'm considering and integrating?
Yeah, absolutely. The biggest challenge is that, back in the days we were solving for private MPLS connections, low bandwidth, high costs. SD-WAN comes along and says, hey, we're going to securely be able to deliver wide area networking, higher throughputs that you can get on internet circuits. And we're going to deliver some level of resiliency for failover between these connections. I think every SD-WAN vendor on the market went out and solved for that perfectly fine. I think where the differentiator came was fundamentally exactly what you said, that the workloads today are no longer 100% sitting in the data center. So most customer environments, there's some hybrid version of SaaS adoption, cloud workloads, and still some legacy applications sitting in data centers. So therefore, how do I actually route to all these traffic requirements? And number two, how do I deliver against the user experience and health across all of these? And that's been the biggest challenge we feel that traditional vendors have struggled with, because the methodology of routing has not changed from back in the days. It's still the same. And so that was not factored in as far as how I was going to identify the health of that connection to a SaaS application. But with me, I have Graham, and I actually wanted Graham to kind of double click on exactly what we do around routing and when it comes to Prisma SD-WAN.
So Graham, let me pitch this question at you then. So there are, I think, a lot of people that are familiar with the SD-WAN paradigm in the way that looks now. Like, okay, I got a series of overlay tunnels. They are
Yep.
interconnecting a whole bunch of different resources. I've got some kind of an off-ramp that gets me to my SaaS services and
Yep.
still has some kind of security there.
Yep.
All right, I'm measuring latency loss, jitter measurements, and so on, trying to
Hmm.
figure out how I'm going to best make that connectivity for a good quality of experience. So from a Palo perspective, Graham, what does that look like? And I ask it in this context. Most
Yeah.
of the SD-WAN and SASE solutions look kind of the same, but you guys have made a big deal about being kind of different.
Yeah, so Ethan, with Prisma SD-WAN, right? First, we'll start with you talk about software defined. Prisma SD-WAN truly is software defined, where we have a controller that completely understands context and state, right? So creating of a site, creating of a data center, that is all things that that controller is completely aware of. So we didn't just take a router or firewall and just layer on some orchestration to build VPN tunnels and overlay routing, right? So first and foremost, right, our state under controller understands context when customers are building out these topologies. So when you ask the question, what does routing do for us, right? I really think of routing being broken down into three fundamental phases, right? Routing protocols help us build topology, they help us with reachability, and they help with path selection, right? That's the typical use case that customers are leveraging with routing protocols. With Prisma SD-WAN and a true software-defined system, we don't rely on routing protocols to do any of that for us. First and foremost, topology is built based on that controller state and understanding of branch location. So when I go in, I create a branch, I create a data center, the system is already aware of that topology and can build out the VPN connectivity without any requirement of a routing protocol, right? I can have cloud data centers, physical data centers. I could have SSE POPs. All of that topology can be built without the need of a BGP or any overlay routing protocol to begin with.
Hold on. Are you saying that that happens underneath without a network engineer having to do the configuration, or are you doing something that, are you saying you're not using BGP at all?
We're not using BGP across the fabric at all. And so the network engineer states, Drew, to your point, I've got a branch site in Santa Clara. I've got a branch site in New York. The controller understands the context of those locations, and then they could create an SSE POP in any of those regions. They can create data centers in the region. And the controller basically, as a software-defined concept, builds that topology for the customer. I don't need BGP to do that. It has context-aware state of where those are located, what circuits are each location, how to build the fabric. Topology creation, I don't need routing protocols to do that for me. And this is important because it's not only the formation of the fabric, but it allows us then when we actually start to make decisions, I'll talk about in a second, we don't have to rely on routing protocols to make intelligent decisions.
You don't have to rely on routing protocols to understand that topology, but there's still an understanding of topology. There's got to be discovery that's happening or something that's happening to understand where those pops are in relation to one another, relation to endpoints, and so on, because you have to have some kind of metadata knowledge about all that stuff to be able to make forwarding decisions.
Correct. And so that's what the software-defined controller in the cloud is doing for us, right? When you create a site and you provide a location and you attach the circuits to the site, it is doing that for you. So as a network engineer, right, I create my sites, I attach my circuits, and then the controller is responsible for forming that topology, right? Providing me the best connectivity into whatever the closest pop is, right? Connecting me to all my data centers, whether it be physical or cloud. So absolutely, this is where the software-defined approach is happening, right? Is that it's creating that topology for us without the need of a routing protocol to establish that.
The topology is going to be my base layer, but then particularly if we're talking SD-WAN, ideally there's also some kind of application context because I want to do application-based policies around performance, security, and so on.
Yeah, so three things. Remember when I said at the beginning for a routing protocol, when I think of BGP, OSPF, I think of three things. I think topology, I think reachability, and I think path selection. So talked about topology. If we talk about reachability, it's talking about where do prefixes, where do applications live, right? So once again, with our approach, right, we can distribute reachability. We can tell, hey, the data center that lives in the Northeast, these are the prefixes that live there. The branch that lives in Santa Clara, here's the prefix live here, right? We can provide the context of where these subnets are located all across the globe, right? But I don't need routing to distribute that for me. My software-defined controller can provide reachability to explain where these assets and these applications and these users live. And
How do you
then
know what the applications actually are? Because I need to identify them clearly, as I'll have different forwarding considerations depending on what they are. Interactive stuff is different from file transfer.
absolutely. So that's where it gets into path selection. And this is where the key becomes into play. We don't use routing protocols to make decisions based on paths, right? We use real-time application metrics and our abstracted path policy to define how you want to forward traffic. So I'm not messing with BGP metrics, all those things that you would typically do to steer paths in a direction, right? Instead, I can write policies that say, hey, I have these critical applications. These are the SLAs that define them. I want you to monitor every single flow. And this is where we'll get into really what one of the differentiators for us is that we're looking at every single flow and we're making decisions based on looking at the round trip latency of a packet, the TCP connection state, and using that and using an SLA, we can say, these are the paths I want you to take, right?
Okay, you just answered my next question, which is in a lot of routing systems, I might use some kind of a metric that's endpoint to endpoint, or it's router to router, something like
Mhm.
that. Tell me across this link what my latency jitter loss profile looks like. I don't really get the whole picture. You're not taking that sort of a measurement, doesn't sound like. You're actually looking at flow data and interpreting what TCP three-way handshake as part of it, maybe other things to determine round trip time and so on.
Absolutely. So we will look at network data. We'll consume that like a typical vendor would look at like a circuit, what its latency, loss, and jitter is. But beyond that, we're also taking the application metrics. So to your point, brownouts are super common, right? And as we see traffic shift the SaaS apps, direct internet to SSE, how can I validate that I actually have application connectivity? Well, I want to look at the TCP three-way handshake. Did I get to three-way handshake? If I don't, that path is not valid, even if it's healthy as can be and I can reach other SaaS apps. For that particular application, for that particular prefix, it's not healthy for me. I should isolate that out and pick a different path. But we go also beyond that. Now I've established a connection, let's say to Salesforce out direct internet, right? I've got a three-way handshake. What's the round trip latency, right? We're going to continue to have requests for application traffic across that session, right? I want to monitor what the network connection is for that round trip, right? I want to make sure that it continues to meet my SLA requirements. And if it doesn't, I can move that. And then beyond that, right, we're giving tools to engineers that, is it a network problem? Is it an application problem, right? We can look at things like server response time. I sent a request for data. Did it take 10 seconds, 20 seconds for it to come back, right? Because the common problem you will see is, right, hey, is it a network, is it an application problem, right? We can solve for network issues, but we can help identify application problems to drive the root cause mediation and give engineers the ability to solve that quicker, right? So being able to then go back to the application team and say, hey, there's a problem with the database, right? There's a bad drive in that database. It takes significantly long to get that traffic back to us because of the server response time.
How do you handle path selection for something like UDP if I don't get that three-way handshake to start making measurements from?
Yeah, so things like UDP we do for like DNS traffic, right? We'll look at two-way connections between that. But with UDP, we can still use network connection conditions. We can do synthetic probes for UD traffic as well, right? So all of those things are still options to us, right? But we're taking not only network SLAs, but we're adding in application SLAs. We're leveraging also, if we need to, synthetic probes. All that information can be leveraged to make intelligent path decisions without the need to modify any metric on a routing protocol.
Synthetic probes. Oh boy, we're talking like you take me back to my application performance monitoring APM days. But that those are still of a use case, don't they?
They do. But and to be clear for us, right, this application intelligence is on by default. So when customers get the system and then they deploy it, they don't have to go tune apps or anything for this intelligence. Right off the bat, we're going to be connecting every single flow with this TCP states, looking at round trip latency, looking at server response time. All that is just natural to the system, right? They don't have to go change that. It's there.
And if you think about it, Drew, one more thing on that, the probing that we do at the application layer. When you think about SaaS applications where customers have lost control over that application, where traditionally where it sat in the data center, they could control it, they could deliver an SLA, they could go and isolate a problem. Now they're reliant on calling Microsoft or Salesforce or whoever the SaaS vendor is and saying, hey, we're seeing issues with our users connecting to your application. Highly likely that SaaS vendor is going to hang up the call with you and say it's your network, not us. So given that we track every session through the system, we're also registering the endpoint within Salesforce and within Microsoft that user is communicating with. So if I have users all over the world and parts of the world are having issues with Microsoft or whatever SaaS vendor, we'll be able to actually track that these specific prefixes are the ones misbehaving. So when we do call that SaaS vendor up, it's a more informed troubleshooting exercise with that SaaS vendor, not just, hey, your app's not working.
All of this has a very different feel from what WAN traffic looked like back in the day. So everything was very circuit focused before. Now there's all these other elements that come into it because whereas if it was a circuit problem, you could go to the carrier and go, we have a circuit problem and look, this is what we're seeing. Can you make it better? And then the carrier would dig in and they'd figure things out. Now I mean, the internet's going to be the circuit probably, you know, in some flavor or another. And
Yep.
therefore, getting to the bottom of what the performance problem is requires not just an understanding of the circuit, but then also what's beyond the circuit, all that middle mile stuff, and then also the application. Oh, it's a SaaS service we're consuming. How do I know that it's the SaaS provider that's got a problem as opposed to something in the middle or my own last mile? And this is where we're getting to, where these are all the things that have to be both considered from a forwarding perspective and then from a visibility perspective. You have to know exactly where the problem is so that you can maintain those SLAs that you need to maintain for the business. It's just a different animal now from what it was not all that long ago.
Yeah, you got it. And in fact, this has been the biggest challenge that we've seen from customers is that back in the days when we were running traditional VPN technologies on routers, it was always like, hey, we don't have visibility. We think we have congestion, so we're going to call the carrier up and say, I need more bandwidth. But it was a blinded exercise that we used to do. Today, we have every vendor gives some level of visibility into the application profile, the utilization against it. The step above that that we've taken to isolate this, and I'll give you a perfect example. One of our customers, it's a global bottling company, and they were challenged with the SaaS application for over a year, and they were having performance issues with it. The users constantly called complaining about it, and every time they called that SaaS vendor to troubleshoot the issue, obviously the finger always got pointed back at the customer's network to the point where the customer was convinced that the switches and wireless that they had were 2, 3 years old and said that highly likely it's your hardware. Go and refresh your hardware and it will probably fix the problem. And the customer actually went through that exercise.
Wait, so this was the bottling company telling their customer to go buy new hardware?
The SaaS company was telling the bottling company, you need to go and refresh your hardware, switches, and
Wow.
wireless. And so the customer did it, and the problem still was there. And so
Oh,
finally, we got our way into the opportunity, and we said, give me your worst site, give me the site that users are complaining the most. And exactly what Graham explained around the ability to track the application performance all the way to the SaaS vendor, we were within 5 to 10 minutes, we started collecting this data. We could see that the application response time was really high at the site. And we had the data because we were tracking the destination IPs that we were talking to. So we reported back to the SaaS vendor the data we were seeing, and the support guy hung up the phone. And within 10, 15 minutes, he calls us back and he goes, how's the app working now? And now all of a sudden the problem went away. Performance was good. So we asked him, like, hey, so what changed? And he says, well, when you guys were trialing the software over a year ago, you were in a sandbox environment. For whatever reason, they never migrated you over to the production environment. So we were able to isolate that
oh,
within seconds.
Wow. Did they also offer to comp them on the CapEx on all the new gear?
right. Okay, there are more questions that we got to ask here. We got to dig into this even more because another element of protecting the branch is where are my security services coming from? Again, because of cloud. So there are solutions where you can bake it all into a box. There are solutions where I'm using a cloud-based security service in order to get the protections that I'm looking for. How am I dealing with this from the Palo perspective? Do I have a box that's doing that? That's a CASB and a secure web gateway and 15 other things that fall into the SSE umbrella? Am I farming that out to cloud services? How does that work?
Yeah, so I'll talk high level and then I'll let Graham kind of double click a little bit deeper into the mechanics of it. But fundamentally, our full SASE strategy is that the Prisma SD-WAN platform delivers best of breed SD-WAN functionality, and our Prisma Access component delivers best of breed security. Now, our Prisma Access portfolio is fundamentally a suite of different security solutions. Depending on the customer requirements, they can subscribe to any one of those, right? So if they just want firewall as a service and SWG, they can. If they want CASB DLP, they can attach that. So regardless of the requirement, the SSE solution that we deliver basically gives you that capability.
And just to be clear, Prisma Access is I'm getting these services, SWG, CASB, firewall as a service, delivered via a cloud, usually from a cloud pop.
That's correct, yes.
Okay. So I can plug my SD-WAN or essentially take traffic from my SD-WAN and say, traffic X needs to go, can go direct to the internet, traffic Y needs to go to the SSE.
That's exactly right. And one of the cool things we've done since acquisition is that essentially, if you think about SD-WAN and all the goodness the SD-WAN delivers, many vendor solutions on the market, it's a like you have to have a like for like box on either end. So when you think about like line conditioning techniques like FEC and packet dupe that we are accustomed to in wide area networking, It only operates if you have the same vendor box on either end. But when you have to go down the path of an SSE model and you say vendor A is my SD-WAN vendor, vendor B is my SSE vendor, I lose all the goodness of SD-WAN then, right? So once again, part of our strategy on delivering a full SASE, single vendor SASE solution was to ensure that we maintain the SD-WAN capabilities, even if you're attaching to our SSE POPs.
Okay. So in the early days, well, I guess maybe the middle days of SD-WAN, once they, everything was straightened out with, link selection and so on, application identification, they started to bundle on security services, firewall, CASB, and so on. And so you got this big box that was doing a lot of stuff. Now a lot of that is moving off to the cloud.
Yeah.
How is that? What's the customer uptake? Are you seeing folks getting comfortable with putting these security services in the cloud as opposed to having them on the box where they can see them and touch them and stroke them?
Yeah, I think there's a mix of customers out there. There's some that still hesitant to go down the cloud route for security, but we are absolutely seeing an uptake. Like I said, been here several years, and more customers are now there's projects of single vendor SASE or SASE in general. And I think the guidance here is fundamentally, if you think about it, we've lived in a world where anytime we turned on any sort of IPS, IDS, or threat on any physical appliance, we've been hit with a performance hit, and then it's always a discussion of, do I really need this? Can I shift this functionality in the data center somewhere? And so that's kind of what SSE or Prisma Access has solved for, is that if I do want to turn on SSL decrypt and threat and all these things that normally take performance hits on physical appliances, I can basically do that at scale using our cloud architecture. So this is where you get not only the unification of management and central management across global sites, but I also get better scale and performance out of it.
If I have Prisma SD-WAN, can I connect to a third-party SSE?
Yes, you can.
Okay.
Packet walk me from my edge device at the branch into the SSE service and then to the resource I'm actually trying to connect to. What's that look like?
Graham, you want to take that?
Yeah, so Ethan, so as part of our single vendor SASE, right, when you onboard a Prisma SD-WAN branch, connectivity into the SSE is just part of the native. So you can basically say, I want to connect to Prisma Access, right? Using basically knowing the site's location, the latitude and longitude, we'll pick the best preferred POPs for the primary and backup connection. So we'll give you POP resiliency.
And stand up a tunnel of some sort, maybe?
It'll create a tunnel into what Mitesh was saying is it also will bring that SD-WAN intelligence as part of that fabric as well. So you want to have things like native monitoring on tunnels, it's there. You want to have protection with things like, packet duplication effect. Those are things that we'll be doing. So natively, we're going to build that out.
But you guys have built that for me, effectively.
Correct.
I'm checking boxes, whatever it looks like. That tunnel gets stood up. I'm not managing what that tunnel looks like. It just is there.
Absolutely. Absolutely.
That's right, Ethan. So if you think about one of the first things SD-WAN delivered on 10 years ago was zero-touch VPNing, right? Remove the complexity of manually having to establish these VPN tunnels. So we made sure that even if you're connecting to our SSE solution, you maintain that same construct of zero-touch VPNing.
But I'll take it one step further, Ethan, just so you understand. It's not just connectivity. It's the whole establish of even reachability. So for example, when you connect this button, right, there's no need to do any configuration of routing protocols or anything that you literally just say as an engineer, what traffic do I want to send to Prisma Access? And I can send everything. I can send public, private apps. All of that will just just work. Right. So, when you do that connection button, it's not just Tom will bring up, it's that entire reachability. And then you can specify which apps you want to send up to the cloud.
And when I'm sending them, so I've got a tunnel that's been established now, and let's say we're going through SWG, Secure Web Gateway. That functions as a proxy typically. So I'm sending that traffic through the tunnel. Well, my endpoint at my branch is going to route that traffic through the tunnel. It's going to appear at the SWG and then get proxied to the endpoint, the resource I'm actually trying to connect to.
Yeah, so obviously it's public app, it's private app. So if it's a public application, it'll take it directly out to that SaaS app. right? With the set of security controls you apply to it. If it's a
Well,
private
so that's what I want to
application,
clarify. You say
yeah,
direct. So am I going up the tunnel for like an authorization and then I make a direct connection, or am I
no,
actually proxied through?
it's proxied. So it'll
Got it.
come out of that POP locally, out of that POP to that resource, right? And then it'll come back through the POP back down to the branch
Okay.
with the
Got
full set of security stack that you apply to it, right?
it. Hmm.
And then, Ethan, to your point, from a private application, it'll come into that POP. It'll ride our hyperscale backbone to wherever the destination is, whether that be another branch in a different region, whether that be to a data center or your private cloud that you have connected to. It'll use that hyperscale backbone to get to that private resource.
Hyperscale backbone, as in this is a Palo Alto Networks backbone built on top of hyperscalers that are out there.
Yes.
Correct. GCP. Yep. AWS.
Got it.
And this topic comes up quite a bit in that, hey, we've seen hyperscalers have outages throughout our time and experience with them. So what do you do for resiliency there, right? So that's exactly why we actually ride on multiple hyperscalers, so that if a particular hyperscaler is affected in one part of the world, we have backups with alternative hyperscalers, right? So the impact to the customer is minimized.
Cloud providers don't have outages. What are you talking about, Mitesh?
Yep.
So if we're talking about tunnels and encryption and applying security controls, obviously in some cases I may want to have payloads inspected, but if it's an IPsec or a TLS connection,
Mhm.
what happens?
Yeah.
So from an inspection standpoint, obviously, if it's TLS, then you'd have to do certificate printing in that. If you want to do decrypt and you want to really look into the payload, that's a choice the customer makes on what level of inspection they want to apply against that set traffic. So that functionality is available. Obviously, there's additional work that's required for that decrypt of that
Sure.
application.
Yeah.
Yep.
Okay, but you can't support that if I decide I
Absolutely.
really need it.
Yes, absolutely.
Zero trust is still a thing. It's not as trendy as it was maybe a year ago, but it seemed like it's starting to be baked into almost all of these branch and remote access solutions. How does zero trust factor in here with your branch networking solution?
Yeah, so from our standpoint, if you think about like you said, I think zero trust has been out there for long enough. It's been a buzzword in our industry, and every customer is in a different journey on it. It's a good conversation starter. In reality, I don't think any customer is 100% there yet. And obviously, because there's multitude of vendors in every customer environment, it's really a combination of delivering it across all. So, from a Palo Alto Networks platform standpoint, what we said is that we have to first unify, in order to deliver least privilege access, we have to unify the identity across all the platforms we sell to our customers. So, whether it's a firewall, a physical firewall, a VM series firewall, Prisma access for cloud security, and/or Prisma SD-WAN, we unified on the construct of what we call App ID, User ID, Device ID, which then allows me to say, first, I need to make sure, what am I looking at? What is the application I'm looking at? What is the user I'm looking at? What is the device I'm looking at for IoT, OT use cases? Now that I understand that, now I can actually apply a security policy to say, okay, now going back to the least privilege access is saying, what are they allowed to or not allowed to communicate to? And the beauty of actually implementing it in a unified management platform as well is then taking to the next layer to say, I want a consistent behavior, no matter what part of the world this user goes to, that this rule follows that person, whether he's in an office, whether he's sitting at a hotel, or he's on a plane on an airline connected to the network, right? It doesn't matter. So that construct was baked in right from the beginning to ultimately establish that zero trust footprint across the entire solution.
So App ID, typically that's done a variety of ways. There's signature databases you can get. You can look at port and protocol. You can look at DNS. You can look at IP addresses and so on. What are you doing around device ID? Does this mean I need an agent, or can you do other ways to figure out what kind of device this is so I know what policy to apply?
Yeah, absolutely. So, Prisma SD-WAN for us now is an IoT sensor. So, typically at a branch, all traffic comes through that edge SD-WAN device, right? And in many cases, we'll even be the layer 3 gateway for majority of those subnets as customers look to simplify. So the fact of the matter that we're getting all the information from DHCP, ARP, and even the app IDs. Prisma SD-WAN is looking at all that information and sending that up to our Cortex data lake, which in turn is feeding that into our IoT security engine in the cloud. So as devices come online and they start to communicate, automatically we're going to get information about that asset, and our IT security service in the cloud will be able to start looking and identifying what type of device that is. But to be clear, it goes well beyond that, right? We will continue to monitor those traffic flows across Prisma SD-WAN and even out to the SSE to get a better identification, not just that it's a Windows, but it's a Windows operating system, it's XP or whatever it is, right? And we'll look at traffic flows for what the device is and give you information to saying, hey, is this normal traffic patterns for what this device is doing, right? Are there any known CVEs out there? So Prisma SD-WAN becomes our sensor to gather all that information to feed it to IoT as our cloud security service to be able to identify and provide posture in terms of what that device is doing.
So we're talking about IoT devices. Do you also apply that to laptops, phones, and so on, or do you have a different approach for that?
Yeah, I mean, any device that you connected.
Okay, anything that's coming across the SD-WAN gateway,
Yeah.
you're fingerprinting and okay.
That's right.
So obviously that handles the issue of I have a bunch of IoT devices out there that I can't load an agent on, but you guys have the
Absolutely.
wherewithal to identify what all of those devices are.
Yeah, so even headless, and this is actually the critical component because I think it's a huge gap that most customers don't think through is that a lot of these services are actually outsourced, right? So like the HVAC system, the certain services within a building infrastructure are typically outsourced to another company, but it's a trusted company that they partner with. But what if there's a bad actor that comes in? Then what, right? Because that IoT device is still connected to the same LAN segment. Yes, you probably VLANed it off or carved it out somehow, and some segmentation is defined for IoT versus the production network. But still, the person's on network and now has the capability to do malicious activity. And so this is why the behavioral analytics that Graham was talking about, what are the common services a printer talks to, what are the common services a camera talks to, identifying that and then finding anomalies against that and reporting on it, as well as then applying security. So for us, it wasn't just least privilege access, it's also then applying security against it and being able to do risk assessments and as well as security assessments to block bad actors.
IoT devices are typically using wireless for connectivity. There are many WLAN companies who are also providing device fingerprinting. Are you able to interact with those to also help with their identification process, like maybe through APIs or something?
So there's the various techniques around that. Let's just take CapWeb. So if a wireless AP is using something like CapWeb, then I'm highly likely not going to see that traffic, right? So that's what I said. So if I'm seeing the traffic, then everything Graham talked about as far as fingerprinting that IoT device and that we'll be able to handle. Anything that's obfuscated from us, then that's where I think we need to figure out from an architecture standpoint how to solve for that.
Got it. The last thing you talked about was user ID, and that's a big one. How are you incorporating user identity into your policies and enforcement?
Graham?
Yeah, so Drew, I mean, we've got a variety of ways that we can ingest user ID. One, we have an agent, right, from Global Protect that we can take that and ingest those in. So as folks, work at home, come in the office, right, we can leverage that identity. But obviously, there's other ways we can connect into through things like Windows event logs and wireless controllers. So there's other aspects that we can take that identity in. And then obviously through what we call our cloud identity engine, we can share that information across the Palo Alto Networks fabric, whether it be firewall, Prisma SD-WAN, Prisma Access, to have a consistent identity for our users, whether they're in the office, at a campus, or at home.
Okay, and is that user identity sort of expressed the same way across all of the Palo Alto Networks products, like to just simplify it for the operators, or?
Absolutely. So Cloud Identity Engine is a free global resource in the cloud. Every one of our products connects to it. So, if I'm a network architect or security architect, I go in there, I plug that into Azure, whatever my identity services are. and then everyone consumes from that. So it's a consistent format, a consistent naming, of that user that can be shared wherever they are.
I want to shift gears and talk about visibility, which is my favorite thing to talk about when dealing with WAN. Um, the the key here for me looking at branches is if I have a branch performance problem, whether that's a ticket that's come in or whatever it is, how do I know exactly what the source of the issue is? Can you tell me what kind of visibility I'm getting with this solution?
Yeah.
Is it like a separate solution? Is it integrated
Yeah.
within what I'm getting here?
Yeah, so a couple of things. You're absolutely right. It's a fun topic. I always love talking about operational tools because it's funny as architects we only solve for how is the deployment going to be and how it's going to fit into my network. Some poor guy in operations has to deal with it for the next 5 to 7 years to use it to troubleshoot. So fundamentally, from our lens, all the probing and all the insights we shared at the beginning of this call around how the system operates, how we're collecting network health, how we collect application health, all of that's obviously exposed using our tool to the end customer. But in addition to that, we also integrate into different ITSM tools. So, common one that most customers adopt today is like ServiceNow. So we have this construct of Cloudblade. Think of it as basically API integration that we as Palo Alto Networks already established for our customers. So it's like an app store. You go to an app, you download that app, and you put in your credentials and you start using it. Similar to that model is what we've done with these third-party services. So a customer can install the ServiceNow Cloudblade and basically decide what he wants to alert on, what he wants to automatically open tickets against. So to that question you asked, Ethan, in that if a circuit fails, if a link goes down, and because of that circuit failing, there's a dozen overlays riding on top of it, all of that basically then gets correlated by the system and therefore only opens a single ticket with ServiceNow automatically, right? And that ticket will actually have the details of not only the underlying circuit, but also the details of the overlays that sat on top of it. So that when it does come back up, the operator can make sure and ensure that all the overlays are back online again. And once that's established, the ticket will also automatically close itself, right? So the full life cycle of operations and integration into customers' tools that they have is all built into the package.
So you're saying if a circuit goes down and happens to be supporting 12 overlays, I'm not getting 12 or
That's
13
right.
tickets. I'm getting one with
One,
all
you're
of that
getting one.
context in it, though.
That's exactly right.
Okay.
And Drew, that's just one use case to be clear. Like we now built it across. So for example, as many of our customers have, they might have 2 or 3 different networks, right? If I'm seeing a problem with one provider and I'm seeing it across 15 sites, we'll create one ticket with sub incidents for it, right? I'm seeing a problem with X provider. It's across these 15 sites and I'll open one. Same thing from an applications performance perspective, right? We'll look across sites from a correlation to see if that same problem is occurring to be able to really narrow down that problem. So one incident's opened and you can focus on it.
So you answering the question I didn't even know I was asking exactly, because we were talking about visibility was how I framed it. And then you're making the point, it's like, oh yeah, banks, visibility is the easy part. We also integrate all of the visibility metrics and so on with other things that are other systems you may have deployed within your shop, and gave that example of ServiceNow because that's the common one that's so frequently deployed out there. But you said API integration. So in theory, I could integrate my visibility telemetry data that I'm seeing on the Palo Alto network side with any system I have in theory.
That's correct.
I think one thing, Ethan, to understand, and folks sometimes miss this, right? What you see in our portal when you go to it from a configuration, from an operation perspective, everything is an API, right? So it's extremely flexible from a configuration and operation model, right? Anytime we release a new feature, a new capability, a new incident, a new piece of visibility, all of that is automatically day one an API that a customer can consume and integrate into their operational model.
And I think the general theme you heard from these few use cases we just brought up is that we have the data. And given that we have consistent data between network security, user experience, because that whole app ID, user ID, device ID construct, with them looking at networking logs, security logs, I can follow that entire session through. So that what we're trying to do for our customers is fundamentally reduce that finger pointing game, right? And get to the root of the problem quicker. And given that we understand general problems and being in the space for so many years, we can program the system as well to say, hey, when you see this sequence of events, it's likely this problem. And so, do some event correlation, do some adoption with it, and report on it. So that way, coming back to we as humans were the correlators of data throughout time when it came to operations. What we're trying to get to is the true AI ops model in that we have all the data, it's clean data, we have it across network security and app user experience. Now, let's do some magic for customers and actually present relevant data that they can use rather than just raw data.
So in that standpoint of magic, and you have all of the knowledge, so insight into what's actually going wrong between whatever the endpoint is and whatever the resources it's trying to connect to might be present in that ServiceNow ticket that was automatically opened. Hey, it's a last mile problem, or hey, your SaaS service is underperforming, and here's what we're seeing.
That's exactly right. And, obviously everyone's building co-pilots as well. So that's the other piece that, we're bringing to market is that, just natural language querying, exactly how you just described it, the ability to query the network using a co-pilot and it give you back relevant information to that problem statement.
Yeah, so I can't believe we went more than 40 minutes without saying AI, but we did it. So congratulations to us. But since you brought it up, Mitesh, I guess I need to ask what kind of AI ops capabilities can I expect sort of out of the box with
Yeah.
Prisma SD-WAN, or is that sort of an add-on? How does all that work?
Yeah, so no, great question. So look, we're based on everything we discussed at the beginning of this call, all of that logic and AI ML was built as part of the initial development of the solution, right? We've obviously enhanced it even further, integrations into Prisma Access. So now we're giving you more that end to end. So AI Ops, there's a piece of AI Ops that's fundamentally part of the solution, and the customer gets that by default. And then there's some enhancements that we're bringing to market that will be an add-on license, right? But generally speaking, a lot of the base functionality of AI ML is already embedded in the solution.
Another thing that occurs to me is, with Palo Alto Networks being in the SD-WAN space, you can tell me if I'm right or not, but it feels like I think most people think of Palo Alto Networks as a security company because that's primarily what you do, but you're also there's a lot of network operations stuff we're talking about here.
Absolutely, yeah. And I think this is the biggest misnomer about our brand is that, yes, we are a cybersecurity company. We're the number one cybersecurity company in the world. But with every security product, there is always going to be a network element. The question now is how much value do you want to put on it? How much feature functionality and operational value do you want to deliver to your customers? And this is where hopefully you've seen through this conversation, there is absolutely value to be had because from a customer viewpoint, all they care about is delivering a user experience against a set application. Today, they're managing multiple tools, multiple vendors from the branch or the endpoint to that set application. Hopefully, what you can see here is that we're trying to bridge that gap between network and security and ultimately just deliver a user experience to our customers.
Well, Mitesh and Graham, thank you for a great conversation. And thank you for not shying away from some of the detail. I mean, we didn't get into, packet headers or anything quite that detailed, but we still went pretty good into infrastructure and packet flows and how things move around in this sort of an environment from a branch perspective, which is kind of a big deal. So thanks a lot, guys. So for the engineering crowd that listens to this show, if they want to see this in action, maybe they want to get a demo, they want to maybe do a POC on their own network, how would you direct them?
Yeah, absolutely. Firstly, thank you, Ethan, for the time. This was an awesome conversation. If anyone's interested based on this conversation, please reach out to your local Palo Alto Networks sales team. They can engage with us and actually organize what we call a universal test drive where you can play with the solution in your own environment. We can also provide demos and potential POVs if that's of interest to you.
Pitesh Patel, Graham Shepard, thank you again for joining us today, and thank you for listening to Heavy Networking. And thanks to Palo Alto Networks for being a sponsor. If you do talk to Palo Alto Networks about your branch connectivity needs, please tell them that Packet Pushers sent you. If you have questions or comments about this episode, or maybe requests for future show topics, or if you'd like to be a guest on a future episode, you can let us know via packetpushers.net/follow-up. We would love to hear from you. Guys, don't forget that packetpushers.net, that's a website you can actually use. We have no banner ads, there's no popover ads, there's no sidebar ads, there's no inline ads. We have a search bar that gives you back matches against exactly what you searched for, and not random stuff that someone paid us to elevate in the results. When there's sponsored content like this show with Palo Alto Networks, we clearly mark it as such. We want packetpushers.net to be a valuable resource for you and not an encrapified experience. I have been Ethan Banks, along with Drew Conway Murray. We are real people and not robots, as far as we know. If you'd like to connect with us, you can do so via LinkedIn, Blue Sky, or Slack via packetpushers.net/community. And until the next Heavy Networking episode, just remember, too much networking would never be enough.